Welcome to the class of 7505, Reverse Engineering and the Malware Analysis. Today we are going to cover the topic called memory forensics. What is memory forensics? I know some of you already attend the class taught by Dr. Chow on digital forensics. Today we are going to use one class to go over the forensic activity on the Windows memory. We will cover the topic on the relationship between the physical memory, which is mainly the RAM, and the virtual memory handled by the operating system. We shall discuss CPU register, OS memory booking tables, physical model, fact model, segmented model. We shall go over the Windows OS kernel structure, eProcess again. Then we also go over a topic called direct kernel object manipulation, called DKOM. At the last of the class, we shall do some demonstration on a tool called volatility. We are using volatility to analyze the memory dump that I am going to provide to you. That is an interactive demonstration. I have not assigned you to do a lab on the memory dump, but you are welcome to download the memory dump, and I shall ask our TA to post the memory dump in our Moodle, so you can download the memory dump and do some evaluation on how to use the tool by yourself at home. So what is memory forensic? That is a process of acquiring and analyzing physical memory, mainly the RAM, in order to find the artifacts and evidence in a compromised incident. In today's response, that means the incident response on any compromised incident, a lot of threat actors, they shift their offensive techniques to avoid writing any file on the disk. So most of their activity, they exist only in the process memory. Conventional or traditional forensic investigator, mainly they are analyzing the hard disk image by using different kind of tools. So they are not having a lot of experience and also the knowledge to take the advantages of the volatile artifacts contained in the process memory. So this lecture will demonstrate on how memory forensic is critical for malware investigation. Malware must be executed inside the memory. I told you many times. And these binary, in last lecture, I told you some image file, they are usually packed, which is the actual code is not easy to read, not easy to be analyzed unless it was unpacked inside the process memory by running the unpacking subroutine or unpacking function. So the lecture will provide you an opportunity to understand, practice at home, and I just do the demonstration for you on today's class on how to use these invaluable tools from the researcher. They do the reverse engineering and understand the Windows kernel in depth so that they can provide you a tool called volatility in this area. So our lecture's objectives. So we want to provide opportunity to allow you to gain some experience working with the volatility framework and skillful knowledge of Windows operating system, and linked by using some command line inside a Linux distribution virtual machine called Remix. So you can using the volatility framework to detect and respond to advanced malware attack, especially those malware can hide themselves, or some malicious activity happen before you capture the memory dump. So you can take out most interesting information inside the memory of the RAM capture from the physical memory. So we need to understand very important part of the Windows kernel data structure, the ePROSESS structure, so that you can parse not only byte by byte reading the string character, but also by parsing the ePROSESS structure, you may be able to find more meaningful information, structural information inside the physical RAM. We need to learn how to integrate memory forensic with your traditional digital forensic and incident response workflow for better scoping, analyzing, mainly analyzing, documentation, reporting, and also that help you may do the containment and remediation. All this scoping, analyzing, documentation, reporting, containment, and remediation is a part of the incident response cycle that we shall cover in the two lecture later. Today's we use volatility framework. We'll learn how to use this framework to analyze the IOCs, what we call the incident of compromise, the indicator of compromise. We may be able to find a persistent mechanism. Yeah, you refresh the memory when we cover the persistent mechanism about the auto start location in behavioral analysis. Actually, by checking the memory, we can also find the register key that residing in the physical memory capture. So we can identify persistent mechanism from that way. The file dropped, are there any file being dropped to the hard drive? Even though we don't have the hard disk image, but sometimes when a malware try to unpack its content inside the first malicious software called Dropper, we can find the content of file being dropped after they finish the execution of the Dropper binary. All this information also residing in the memory. And some other activity performed on the victor machine or suspect system. Some part we are not really cover, how to prepare the forensic sound memory samples. Here you will find that I said this is not a memory image because memory is so volatile. We can only cap one particular point of time of the volatile artifacts residing in the physical memory. Unlike the hard drive, you can capture the hard drive image many times, provided it is shut down environment, and all the capture will be the same because you're using white blocker to prevent any software or hardware changes make change to the hard drive image. That is an image has been used in the traditional forensic activity, but the memory, every time when you acquire, it may have some impact. Even though we don't cover a lot of how to prepare the forensic sound memory samples, I shall have 1 or 2 slides to cover what kind of tool, what is the pros and cons when collecting these forensic sound sample. So we come to one of the most important topics on memory forensic. What can be found inside the memory? Instead, when we compare it with the traditional forensic disk image, we can find the warning process, even though the process had been terminated before you acquire the memory dump. We may be able to find the active network connection when the time of the image was collected or the memory dump collected. Even though some cases the network connection was closed before the capture of the memory dump. We may be able to find a kernel information about what driver have been loaded to a particular, has been used a particular user process, or even some hidden drivers. Console input, that is terminal input, or clipboard. When you copy and paste, something is kept inside the clipboard. These data, they also residing inside the memory, and you can extract this information uniquely from this console and clipboard data structure contained inside the kernel. So all other malware-related artifacts, including encode the injected code and the views of the past injected code, sometimes they may reside in the physical RAM, but not on the hard drive. Some application information, including the strings and variable of a particular running process. Sometimes in the very old day, you can find the encryption key inside a physical RAM dump, and sometimes more. And we are using the Remix virtual machine, and because usually the memory image dump is at least 2 gig or 4 gig or 1 gig, depends on how the physical RAM was installed in the machine being analyzed. In our virtual machine, usually we kept 2 gig memory. So we configured our virtual machine is 2 gig or 4 gig of memory. Then we may have the same size of the memory dump. If we need to analyze this memory dump inside a virtual machine, will be difficult because there is a lot of activity of running the virtual machine. I don't want to utilizing the RAM or the hardware resources to run the volatility framework together, assessing the image inside the virtual machine. So I create a share folder, which is point to the host folder of my sample. In my example, I name this folder in my host machine as samples. Then we are using a tool, the volatility tool 2.6 that was installed, has been installed inside the Remix machine for you. And actually volatility 3 is coming out, but it is still under heavy development. So we are not covering volatility free. Uh, there is a major change in volatility free and 2.6. 2.6, we can analyze Windows 10 machine up to certain version. As I told you, Microsoft, they pushing out the Windows OS in different names. Maybe in the past you have been using Windows 7 before, and then Windows 8, 8.1, and then Windows 10. Then after Windows 10, each new version of Windows will still call the Windows 10, but they may have a version number. For example, 1904 means version number of the 1904 means the Windows 10 version published in year of 2019, April. So after a certain level, I can't remember exactly, maybe 1805, uh, the volatility 2.6 need to keep up the Windows symbol embed inside the one of their library called VTape library. So they are no more updated. So if you're using Windows 2, using the volatility 2.6 to analyze the volatility, um, to analyze the image of Windows 10 more than 1805, it doesn't work. You need to using the volatility free. And there's a major change on the volatility free is volatility free when you download the volatility free and then run it, it will go to the Windows, Microsoft Windows symbol server to download the latest symbol from your, when it is analyzing your machine, well, analyzing the memory dump. So you can, in my Mac machine, I usually have the mounted drive be found at the MNT HGFS, and then with my host folder name that I create is called samples. So how memory analysis techniques have been used? We go back to the traditional digital forensic on the hard drive. When we analyzing the hard drive, basically we check the physical layer, the hard drive, and then based on the hard drive, we find the hard drive partition table. For example, every every boot setter after the boot thing of the hard drive, the boot setter will be rely on the setter 0, and then by the setter 0, it will be able to find the partition information. And based on partition information, we may need to analyze the data in form of cluster. Yeah, cluster is the multiple size of a fixed size of the hard drive called sector. Sometimes this cluster is equal to 4 sector, sometimes it's 8. It depends on the size of the hard drive and the hardware circuit installed in the hard drive. And based on the cluster, we may be able to find some metadata layer. Here, I would like to draw your attention about how data will be stored in the hard drive. You learn it from the digital forensic class before. If you are not attending that class, you better attend the class so that you can understand the concept of the cluster, sector, and the data. Actually, the data stored at a minimal size of the cluster, not the sector. For example, if the cluster containing 4K of data or format of data, depends on the hard drive's minimum size. If you store some data, I just keep this as a typical example, assuming one cluster is equal to 4K byte, that means 4096 byte. If you want to keep a file on the hard drive, the file only contains the size of a 1000 byte, then the hard drive will keep the 1000 byte of the starting of a particular cluster from the offset 0 to the offset 1000. All this information I'm referring is decimal data. Then the remaining 3096 byte data in a using cluster, it will not be touched. It will not be zero out, but it will only zero out only the in form of the setter. So sometimes maybe the data, when you write the data on the hard drive, if the file size is not fully using a cluster, then some information previously written on the hard drive can be taken out. That is the same logic when we talk about the process, how the binary, how the raw data, how the image file be mapped to the physical memory. Similar like that. So that is the why digital forensic can recover file, why digital forensic can find remnants of some previously saved file in a not a cluster at the plot of that has not been overwritten. So when the metadata layer we concern on Windows system, that is a master file table, MFT table. Based on the MFT table, you can find the file name in which actually at the back, that is a pointer to which sector of the first offset of the first sector. And based on that sector, the hard drive knows, okay, I should go to which cluster to find the data of the file maintained inside the file table, MFT table. Then based on the file name, we can find the directory and file name, and that is the way to find the data on the hard drive. Memory, similar approach, but the layer will be 4 layer instead of 5. First, we shall have physical memory. We can analyze the physical memory directly. But the physical memory doesn't equal to the virtual memory. Later, when we talk about the memory mapping and how the relationship of the memory of the process memory, how the table, how the OS handle the virtual memory table, and how they are mapped to the physical memory so that the memory can be used more efficiently and each process will be protected. Then the OS take a part between the physical memory and the virtual memory. And then we need to understand how the OS process running. So that goes to the part of Windows internal, talking about user space and kernel space. And of course, we based on the each process, we may be able to perform some application analysis. So our technique using in the past, old days, we basically using unstructured way. What is the meaning of unstructured way? If we can dig out any data, if data human readable information, then we try to find it out. If we know a special data structure, we may be able to, based on the structure, to perform a file or data structure carving. And based on this structured way, we may be able to find the exact content of a window kernel object, including the flag, including the process, including the socket, including the clipboard data, including the registry. So the data carving is based on the magic character and the expected size, which is when we map to the this forensic, we can use the tool for called the Scalpel and the Foremost, which can be downloaded from the GitHub. You can play around with this tool to dig out the information inside the physical memory dump as well as a hard drive, because once they encounter a particular file format, then it can take out the information. But the structure is talking about the kernel structure kept by the kernel space. So now I'm going to show you by one of the tool called String or String LA, what they are different to analyze the word memory image. Okay, right now you see on my Remix machine, I have a share folder called the sample, which the sample is showing the memory dump. And I already typed, because I want to save time, I already typed the command called string. For example, EL means the Unicode character of one of the memory dump that called the Win10, the Win8, and then I just want to check the end of the string character that I can dump from in Unicode. You will see, for example, one clear, interesting artifact we can take out from this memory called services.exe. But if we are using the ASCII code character displayed with the offset in decimal on the same image, the last part you will find different kind of information. For example, the KD, PDB, and this program cannot be run in DOS mode. You refresh the memory when we talk about the PE format, right? That part is the showing the exact offset location in decimal character that is seems in this physical memory. If we check the string on the ASCII character, we find there is a structure of the PE file. Yeah, that is the major reason I want to show you in my virtual machine. But right now I would like to show you more. For example, if I want to check the string character, ASCII character in decimal about my one of the sample called the SUSE memory dump and SUSE, and then I try to grab what KDBG, see whether I can find the ASCII character of the KDBG data. Yeah, it is on a fixed location from the offset 55244720. And if we are using a HESI decimal editor, hexa called XXD, if I go to the location from these 5524 something, and then list 80 byte of character of this sample image called SUSE. Yeah, you can see the ASCII character exactly displayed right here. That is the exact offset in the HESI decimal instead of this is decimal, and show you the information. Sorry, maybe